Good. Good afternoon, everyone. My name is Barrett Church. I'm the project manager for Hayman Engineering, as well as one of the structural engineers. With me today, we have Jack Larson, our environmental engineer, Leah Hammond, our transportation engineer, and Alex Ketter, our other structural engineer. So we have the Amazon industrial site project, and with that comes certain responsibilities, one of which being the design of a new academic building, along with the parking lot associated with that. The second being the design of a new road connecting County Road 17 to County Road 19, as well as design the intersections associated with that. And this will provide access to our building, as well as connect the two county roads. And then lastly, to design a water treatment system that will provide clean water to both our building and the surrounding areas. And all of this will be done in accordance with the necessary codes and regulations. So like I said, I am also one of the structural engineers on this project, and with that comes certain responsibilities. My main objective was to design a new academic building of around 30,000 square feet, and this is to include classrooms, labs, offices, a covered outdoor space, and a 240-person auditorium. This will all be done in compliance with the necessary codes, so the International Building Code, the Elkhart County Building Code, the ASCE 7-16 code, as well as any other relevant material codes. So for concrete, it would be the ACI 318 code and so forth. And then lastly, I have to develop and evaluate 3 different alternatives for my building. So the work I've completed so far is first the site evaluation, and this is just determining the best spot for the building with the given constraints of the project. So I researched the site for this, the topography of the site, as well as consulted with the rest of my team on where the best spot to put my building was, and we determined that the best spot is towards County Road 19. As you can see in the figure over there, this is County Road 17, so a little more east in the project. After that, I moved to the load determination, so I determined the various different live loads in my building, so for the different uses, so offices, classrooms, auditorium. And then after that, I went on to the alternative floor plan generation, and I developed the different floor plans for my building for all 3 alternatives. And this included material analysis on what could and couldn't be done with the different materials. So this is my first alternative. It is a reinforced concrete building with around 31,000 square feet of area. As you can see, there's various different uses that I've laid out. Towards the west is my entrance right here. This is a covered outdoor space, and this will be used as a drop-off / pickup area for these students. The auditorium towards the back of the building is around 4,000 square feet, and something unique about my auditorium is what we call a double height auditorium, meaning that it is 2 stories tall, but there is no second floor, it's just one floor. And with this, this will be a vertical irregularity in the design, so that is something I will have to encounter in the design of this alternative if chosen. So my second alternative is the same layout as my first alternative. The main difference is that it is a structural steel building instead of a reinforced concrete building. Everything else stays the same. And my third alternative is again a structural steel building. Now, as you can see, the layout switches up a little bit, and the total square footage of the building is 32,000 square feet, so a little bit bigger than the first 2 alternatives. The entrance is still to the west of the building. However, the main difference is that the covered outdoor space will be in the center of the building, and this will be used as either a courtyard, a hangout area. It's completely up to the client. The auditorium will also be to the back of the building, like the other 2 alternatives, except this time the square footage of the auditorium is 3,600 square feet instead of 4,000 square feet, so a little bit smaller. And again, it will be a double height auditorium. So the future work I have for my portion of the project left is mostly the beam and column layout for each alternative. So this will be different for each alternative just because of the different material tolerances as well as the different layouts for my alternatives. After that, I will move on to the evaluation of the alternatives, and this will be done by a criteria created by the Hayman engineering team that could include, but is not limited to, feasibility, cost, environmental impacts, and aesthetics. And after that, I will select my alternatives based on this criteria that the Hayman engineering team will create. And now I'm passing it off to Jack.
Hello, yes, I'm Jack Larson and I am in charge of the environmental side of this. With this, I'm planning to develop a water treatment plant to supply clean, potable water to the surrounding area. With my plan, I plan to provide about 1 million gallons of water per day to the surrounding area. So far, I've done a site evaluation where I've determined one of the best spots for my plant to be located, as well as the preliminary designs for each of the formats and the treatments of treatment trade for it. My alternative selective, I've gone through those, going through groundwater, surface water, and river water. Starting off first with groundwater, unfortunately I did not have enough time to put in my full sketch into AutoCAD, so for now I will be using sketches from sites listed below that are based on what I plan to design them with. First off with the groundwater, I've estimated that the static water level for where the water will be drawn from is about 50 feet below the ground level. With the soil around there composed of fine to medium sands with zones of coarse sands and gravel, which will allow it to be not to be as filtered and need treatment as say river water or surface water. Continuing on, I'll be doing a filtration device with coursing through sand, activated carbon, as well as disinfection with chemical treatments such as chlorine, pH connection, and UV lights. Finally, going to storage and then distributing out to the surrounding area. Next up is surface water. I plan to take the water from Heaton Lake, which as you can see is about 6,000 feet away from the site projected. For the collection, I plan to have screens with different sizes, 2-inch, 1.5 inch, and 3/4 inch, so that any debris is not building up within the intake pipe and thus causing a clog. With this, the treatment is a bit more complicated. We get into coagulation, flocculation, sedimentation, then filtering it out, disinfecting the water, and then storing it before it's being distributed. Last but not least, we have the river water, where this intake pipe will be placed under the river of St. Joseph Lake, which as you can see is much farther away, about 10,000 feet, where it will also be screened so no large debris will get stuck in there and taken through the intake pipe to the plant. As you can see, it is similar to the filtration system of the surface water, where I'll need to coagulate, flocculate. I'll need to sedimentate and have the sludge from the river water digest and taken away, followed by filtration, disinfection, and then storage. And then future work, what I still need to do is I need to design the water storage system, currently deciding between if I want to do a tank or a large water tower. I need to plan the layout of the design. So far I have a 240,000 square foot area planned out, but that is likely to change. Then evaluating the alternatives, which include the cost, the practicality, and the environmental impacts. And based on all that, from my final decision, I will be moving on to the selection of my alternatives. Next, I will be heading off to Leah.
Thank you, Jack. Moving into the transportation portion of this project. So our design will be extending County Road 4, connecting County Road 17 and County Road 19, providing access to any infrastructure that is being built on this project. For this project, we do have 2 structural engineers. I will be designing to Alex's building because Barrett will not be here next semester. Additionally, I will be providing access to the water treatment facility that Jack decides to build.
Sorry, what did I mess up? Sorry.
Continuing on though, because there is a school being designed, I will be providing access to the school using designs for school buses and also drop off and pick up, streamlining that so it is easiest for students. Additionally, I will be designing a signalized intersection where County Road 4 extension will meet with Toll Road, and also where the County Road 4 extension will meet with County Road 19. That one will be a stop control intersection. So far my work completed has included designing the main roadway as far as the design considerations using the Indiana Design Manual and the Ashton Green Book. And I will be, so I made 3 alternatives with the alignment. And the first alternative is extending with a 3-way intersection, as you can see here, with A. I have designated turn lanes, so after-school traffic does not get backed up. And then where the intersection meets with the road to go to the parking lot to the school, that is a 3-way intersection as well, with more designated left turn lanes. And then alternative 2 extends from this parking lot, the trailer parking lot, where it'll be a 4-way stop signalized intersection. Alternatives B and C remain the same. And then alternative 3 is very similar to alternative 1, with it being a 3-way intersection, but it is off very close to the school, which will be interesting designing for the school buses and pedestrian safety, as well as drop-off and pickup traffic. Future work is evaluating each design. Considering efficiency, cost, and very weak. Sit down. Sorry. Would you guys mind continuing with the presentation?
Yeah. Okay. So moving on to the structural scope, my project objective was to build an academic building, and this building is going to be about 30,000 square feet, to include labs, offices, classrooms, and an auditorium that'll seat about 240 people. It'll also include an outdoor covered area. All this will be done in compliance with codes such as CEE 7-16, Elkhart County regulations, and international building codes, anything that would be needed to build the building total. This also includes 3 design alternatives. The work completed so far, I've done a site analysis. This is also included complying with my environmental and transportation counterparts to decide where the best place to put the building would be. And as you can see, it's just right there on the right by County Road 19. This also includes load determination and code compliance, going through codes and figuring out the live loads for what is inside the building, such as the labs, offices, the auditorium, and so forth. Next includes, I've done the design alternatives, which includes the floor plans for each floor. I'm building a 2-story building. And then the material selection, I've done research for that too. Moving on to the alternatives, I know it's kind of hard to see right here, but my first story floor plan and second story floor plan. Right here, this yellow box is kind of off, but this is my covered area. This will have a lane for pickup and drop off for kids and students, and an area that they can wait to kind of congregate and go into the school. On the very far right in the green box is my auditorium. Kind of like Barrett, my auditorium is a full 2-story room, so it will not be included in the full square footage as both floors, because there's 2 separate floors, and that's about 6,000 square feet, and the building itself is about 32,000 square feet. And then also in the middle is kind of the classrooms, labs, and office areas, which also includes means of getting up and down with the elevator and stairwells. And then moving on to the alternatives, I decided to do one real design. And then that includes the alternatives are just different materials for each building. So reasons why I kind of chose concrete in that research was the allowance of the bearing that it can hold. You're gonna need a lot for 2 stories. It's also very durable. And then moving to steel, steel is also a high bearing load. You can carry a lot with steel, and also a lot of it can be prefabricated off-site and moved on to the site to help speed up the process of construction. Lastly, timber. Timber is more of the eco and sustainable more side of things other than steel and concrete, and it is also a lot quicker to construct. And moving on to my future work, it all includes beam and column plans for each design option and a comparative analysis for the alternatives, which will be done with my team. And that includes the feasibility, cost, environmental, and sustainable impacts of the project, and obviously the aesthetics. We want the project to go well and look good for the client. And lastly, the final selection will be decided of the alternative that we choose to go through, and that will be based off the criteria that was just listed. Then lastly, we have our design cost estimate. All this includes in the hourly rate. Our hourly rate includes our overhead burden, and our 10% profit margin, which is all included and calculated in the hourly rate. It includes our disciplines of our project manager, our 2 structural engineers, environmental and transportation engineer, also including our administrative director and survey subconsultant, and all of that totals to about $66,000 in total so far. Are there any questions?
Question number 1. What are you planning to do with the drainage from the parking lot?
Which one are you asking?
Who are you asking, Professor?
Yes.
Just anyone?
Where,
Well, that is not really my scope, that is our transportation scope, but I'm sure we will have a curb and gutter system or sloping down into a drain. So,
and the drain is going to go to the sewer or is going to go to other place?
I do not know that at that time. I would have to.
If you were asking if it's going to the water treatment plant, I would have to say no. It will likely be drained into a sewer system, but as that's not my area of study, then I cannot comment on that.
My point is the parking lots are notorious because of the leaks, yes? That means the antifreeze, the braking fluids and all that. And normally that is a headache for other projects. For example, the Walmart in West Lafayette had that big debate with the community because there was a block next by. And the excess of the water, the rain, was going to the block. And nobody wants that. But that's the origin of the question.
I'd say we don't have the knowledge at the time.
How much space did you say the water treatment plant would take?
Currently, I've been estimated at a 240,000 square foot area. That is going to be subject to change.
And that's for any one of those alternatives you think?
Correct, yes.
That's basic.
Yes, that is just a rough estimate. As of right now, if I were to be using the groundwater, I'd be having that system with the AMP water treatments. If I use one of the other alternatives, it would likely make the site a bit smaller, but we'll get to that once I evaluate the alternatives.
Anyone can ask questions,
Any other questions?
With respect to the water treatment plant, are you foreseeing the new pollutants that are going to be regulated? Okay. The normal water treatment plant is only for sedimentation, for turbidity. Are you considering any other of the new pollutants in the environment?
I have not, what do you say, like stuff you would use, like stuff I'd be gathering, like farming pesticides. I have not addressed that yet, as this is not close to farmland or any other sites. But I will look into that during my during my evaluation and designing of the treatment train.
You're right, yes, because the nitrates is coming. It's going to be treated as one of the pollutants to be treated. Plus other ones, emerging pollutants like the PFAS. That's another story.
And I will look into that. I will look into that treatment of those pollutants.
Any other questions?
Okay, thank you.